So this is G485 homework booklet question 14. So the first question asks you to state and describe one way in which X-ray photons interact with matter. That one way under state and describe is very, very important. It'd be very tempting to mention a number of ways. It would also be tempting to either just state or just to describe. We've got to state and describe. We've got to do it for one way. Your three options are obviously the photoelectric effect, Compton scattering, pair production. The description in each case, the idea of the electron being ejected from the atom. I would probably also add in there, and the photon, that should say photon, not photo, just there. The idea of the photon being fully absorbed. With Compton scattering, the X-ray photon is scattered by the interaction with the electron, and the electron is ejected from the atom. And then in pair production, the idea of getting an electron and a positron being produced, matter and antimatter, which we can do directly from energy, an electron and a positron being produced, and that comes about by interaction of the X-ray photon with the nucleus. Part B, we've got a collimated beam of X-rays reduced to 10% of its initial value after passing through 3 millimeters of soft tissue. Calculate the thickness of soft tissue that reduces intensity to 50% of its initial value. Now, with X-ray intensity, if I deal with the thickness and stick to that in millimeters, that's fine, as long as I'm happy that any value I end up with of mu is per millimeter, in exactly the same way as with half-life and decay constant. That's obviously fine as long as I stick with, if I for example did half-life in years, that's fine as long as we're happy that then gives me the decay constant in per year. So the information we know, essentially, starting from I equals I naught e to the minus mu x, the information I've got is that 10% of that is equal to e to the minus mu times 3, sticking in millimeters. And this is quite a neat solution. That gives me 0.1 is minus 3 mu, which I can then take logs off, and I get log of 0.1 is minus 3 mu. And I've also got that 0.5 is e to the minus x mu, where x is the thickness I want. Again, take logs, gives me log of 0.5 is minus x mu. And then rather cunningly, I can, to get rid of those mu's, which I don't know and I don't need to know, I can simply divide one by the other. And I get that equation, that log 5 over log 0.1, so that divided by that must be equal to that divided by that, which gives me x over 3, and I can work that out and give me x equals 0.309. Of course, I could at this stage have worked out what mu was and then plug that back into that equation to work out x. That would work as well. It's slightly neater mathematically this way. Now, Part C is a lovely illustration of what in the past has been at least some confusion by the exam board on image intensifiers. We've got here, we're told that X-rays are used to image internal body structures. Thank you very much. Explain how image intensifiers are used to improve the quality of the X-ray, and crucially, pencil mark G485. We've got in your answer, you should explain clearly the process involved which makes the image brighter. So G485, the quality of written communication marks tend to be of this format, where it's about clearly answering a particular element of the question. Be careful, sometimes these are almost an additional element to the question, and it's really important to read those. Now, frankly, the mark scheme for this was imagining a image intensifier tube. The mark scheme just about allows you to use the image intensifier screen as well. Poorly worded question, and it's not absolutely clear which they were after. So if you're answering in terms of the tube, you could have the X-ray photon hitting the phosphor. I think I probably really should have photon in there. The X-ray photon hitting the phosphor, that releases visible light photons. Those photons are absorbed by the film, and we have more visible light photons after the phosphor than we had X-ray photons before, and they're more likely to be absorbed. So that third point there is doing the pencil mark point. 3 marks, one of those marks will always be for the pencil mark point. In terms of the image intensifying tube, we've got X-rays hitting the phosphor. That's releasing visible light photons, and those released photons go on to release electrons at the photocathode by the photoelectric effect. We've got more photons, visible light photons, due to the phosphor than we had X-ray. Therefore we get more electrons than we had X-ray photons, and that again is the point that's answering that. 3 marks only there, and you've got to work out whenever they refer to an image intensifier which better answers the question, the tube or the screen. Sometimes you can find a context for that from the question and have a look at 15 where there is a context which makes it clearer which it is they had in mind. Sometimes you don't, you've just got to go for it. I think here you could do a reasonable job of answering either way. And then just for 2 marks, explain how contrast media are used to improve the quality of the X-ray image. So it's an explain question. So you need to peel back one layer to the idea that different soft tissues have similar Z values, so have very little contrast. They're all made up of carbon, oxygen, hydrogen, those kinds of atoms, relatively small and similar Z values. Contrast media are used which have got high Z values, and they may be either injected or ingested, drunk essentially, to then go and outline. Now again here it's worth looking at question 15 as well, with slightly different emphasis in the mark scheme, and putting those two together gives you a good idea of the kind of things that you should say. That's G485 homework booklet question 14.